Welcome, everyone, both offline and online. I hope you can all hear me well. My name is Savo Zavreti, and I'm very glad and happy to have all of you here with us at our Stakeholder Forum on Agricultural Plastic today in Athens, both with the MINAGRIS and the PAPILLONS project. We have a full day, very packed, with a lot of speakers. So we're very happy to have all of you on board to have different facts and perspectives on the topic. In the name of both consortiums, we're very much looking forward to this event. And I would like to introduce both our project manager and coordinator, who will address you with a couple of words on their own and let you know on housekeeping rules as well. So first, I would like to invite Luca Nisotto to the floor to give his opening speech on a little bit of context on why we're here and what we will be listening to. Luca, please.
Good morning, everyone. It's a pleasure and an honor to introduce this context, the Stakeholder Forum of PAPILLONS and MINAGRIS. For those of you that haven't had the chance to know about these two projects, PAPILLONS and MINAGRIS are two research projects financed by the European Commission that are dedicated to investigate the ecological risk of micro and nanoplastic in soil environment from the use or mismanagement of agricultural plastic. This is a topic that is entering the international agenda, also in the context of the global negotiation for the plastic treaty. So what you see here is an image taken at the electronic microscope of a fragment of particles made of plastic that specifically is a piece of mulching film. Mulching film are plastic film that are utilized to improve agricultural performance of soil. Unfortunately, during use or post-life, they can, when they are mismanaged, they can result in fragmentation, they can degrade and produce this type of particles that can accumulate in soil. And there is a concern that intense accumulation of micro nanoplastic in soil can cause adverse impact on the soil ecosystem and eventually also on the agricultural performance of soil and soil fertility. So we will tackle this research by addressing ecological impact on soil microinvertebrates, soil microorganisms. We will look at the impact on plant growth, soil fertility, and eventually we will, in order to do that, we will deploy a quite ambitious set of experiments covering both field scale down to the laboratory scale. So we are doing that to enable scientific informed development of measures, policies, and innovation also possibly in the industrial sector and regulatory sector as well to solve the problem and prevent accumulation of soil pollution. Thank you very much. I give the word. Hopefully we will fix this technical problem. Sorry for this inconvenience. Yeah.
Hi everyone, and welcome to this meeting. I'm sorry for this first hiccup. I'm very happy to see so many of you. We've had, for those that are new and just arrived, we've had now very nice 2 days of consortium meeting, actually 3 days of consortium meeting. And I think we got quite a good progress, and it was very nice because it was the first meeting we actually met in person. So I hope you have a really great 2 hours. And I give the floor back to Szabolcs. Thanks, Szabolcs, for moderating today.
Thank you very much for introducing both the project, the objective, and why we're here today in a bigger and larger. Who is here with us? Richard Thompson. He has been a chemicals and waste consultant with experience in agricultural plastics within the UN. Therefore, we would like to ask him to start today's discussion giving a bit of overview on the work that FAO has done on agricultural plastics and on maybe the future, what we can expect. We'll soon hear more of it. Richard, please.
Cool. And okay. Good morning, everybody. Thank you very much for inviting me to speak at this event. My name is Richard Thompson. As you heard, I work with the United Nations, the Food and Agricultural Organization of the United Nations, and I'm going to be speaking today about improving the governance of plastics used in agriculture and the importance of collaboration between all stakeholders to drive these improvements. The issue of agricultural plastics has been growing exponentially on the global agenda over the last 5 years, and FAO contributed to that in December 2021 when it published this report, the Assessment of Agricultural Plastics and Their Sustainability, a Call for Action. It was launched jointly with UNEP and Grid Arundel's paper on soil pollution from agricultural plastics, and Christina is going to be presenting later on this morning for the work that they're doing. And both organizations collaborate extremely effectively, and we're working together to improve the governance of agricultural plastics. So I'm not going to spend a whole heap of time on the report. When you get this recording, you'll be able to see the link to it, and many of you have probably read it. But the global headlines are that in agricultural production, approximately 12.5 million tons are used every year, and that's in crop production, livestock production, forestry, and fisheries and agriculture. In addition to that, there's about 37 million tons used in food packaging, and we don't know the quantities used in storage, distribution, in the midsections of the agricultural value chains. The largest sector is crop and livestock with about 10 million tons. And you'll hear from Bernard later on about their predictions, but back in 2018, they were predicting that it would increase by about 50% by 2030. So it's a growing market. And of course, all these plastics eventually either leak into they become waste or leak into the environment. So why are they used? What are the benefits? So mulching films and drip irrigation, they can increase crop yields, they can improve the growing season, they can reduce water or improve water use efficiency, and they can improve the quality of fresh products. They can avoid mold growing on fruit, and so can reduce the quantities of agrochemicals being used. Also reducing food loss and waste. And with climate change, farmers are going to be increasingly looking at strategies that they can adapt their techniques to be able to farm in the new climate. And the use of agricultural plastics is one of those strategies that they may well migrate to. Coming to the trade-offs, there's lack of adequate collection and disposal of agricultural plastics. Farmers often don't have the capacity to select, to apply, to manage, to use, and to dispose of agricultural plastics at the end of their life. Only a very small fraction is actually collected and recycled. Micro and nanoplastics enter the food chain. There's a concern for food security. And in China, it's been seen that high accumulations in surface soils can have an impact on reducing crop yields. And finally, plastics, the manufacture of plastics and their inappropriate disposal all contribute to greenhouse gas emissions. So in our report, we recommended a process for assessing agricultural plastics. So these benefits and trade-offs need to be balanced. They need to be balanced in a holistic way and across the whole of their life cycle, from manufacturing, distribution, use, and end of life. And there are a number of things that need to be considered. Food security, food safety, nutrition, and the three dimensions of sustainability, so economic, social, and environmental sustainability. And that all needs to be done in a holistic way, both for the plastics themselves, but also for the alternatives, alternative products or alternative practices. And here we recommended that the 6R approach be used for evaluating the environmental options, and that is refuse, so avoid using plastics, redesigning to improve their efficiency, their circularity, and reduce their impacts, reduce the use, reuse plastic components, recycle, and then finally recover. So you can see that is going from the most preferred option to the least preferred option. The report recommended a two-pronged approach for developing policy. Firstly, to support the development of the legally binding treaty to end plastic pollution that Luca mentioned just now. And secondly, to develop a voluntary code of conduct on the sustainable use of plastics in agriculture. So very specifically, a code of conduct specifically on use of plastics in agriculture. FAO has found that, or has developed a number of voluntary codes of conduct, and they can be complementary to the legally binding agreement, and they have been very effective in helping countries to implement national legislation to improve the management of whatever it is. I mean, there are codes of conduct on responsible fisheries, on pesticide management, on reducing food loss and waste, and it's soft law. And these soft law instruments are quicker to negotiate because they're not binding on the countries that are agreeing them, and they can have a broader range of stakeholders involved. They can recommend roles and responsibilities for not just governments, as would be the case in the legally binding treaty. So this is what was recommended. And so that was back in December last year. I am pleased to say that things have moved on. But not the slide, no. Yep, here we go. So in March, here is a picture of the final day of the negotiation of the new treaty at the UNEA, United Nations Environmental Assembly. And they just gavelled a resolution to establish an intergovernmental negotiating committee to start negotiating of the legally binding treaty. That's going to start. The first round is in Uruguay at the end of this year, and they have an ambitious target to complete it, all the 5 steps in the negotiation by 2024. And the second prong has also been effective. So in July, at the Committee on Agriculture, at its 28th session. This is one of FAO's governing bodies. It determines the strategy and mandate for the organization. They discussed agricultural plastics and agreed that it's an issue that FAO should address. And specifically, they asked us to undertake further scientific and evidence-based assessments, to develop the voluntary code of conduct on the sustainable use of plastic, and also to support the deliberations of the International Negotiation Committee for the Legally Binding Treaty, specifically on plastic used in agriculture. So I'm really pleased to be talking to you in the room and those online as stakeholders and researchers involved in plastics, plastic pollution, agricultural plastics. As part of the remit given to us by COAG, we need to do further assessments, and we will be wanting to reach out to you to help to develop first of all, a knowledge map. You know, what do we know? What do we need to know? What are the priority knowledge gaps? And identify all the organizations that are working in the sector so we know what is being done. And then I think it's important that we should collaborate and consolidate the global knowledge. It's possible that there are many organizations working on the same agenda, and there'll be some aspects that are not being addressed at all. It's important that the research agenda can be focused on all the priorities that need to be addressed for solving these knowledge gaps. In the report, we identified a number of knowledge gaps that needed to be investigated. So there's global flows and fates of plastic across the whole of the world, life cycle of assessments of alternatives, the pathways and impacts of micro and nanoplastics, which obviously Papillon and MINAGRIS are addressing, the degradation behavior of biodegradable products, again, something that Papillon and MINAGRIS, or Papillon is addressing, as is the industry, impacts of agricultural plastic pollution, and finally, economic assessments to understand the benefits and trade-offs and the externalities of using agricultural plastics and their alternatives. I would like, this is my last slide. I'd like to make some suggestions, possible linkages for the projects and other stakeholders and researchers. FAO and UNEP host the Global Soil Partnership. It's celebrating its 10th year this year. And it represents or provides an opportunity for you to engage with other researchers and other stakeholders in this world. And they have recently established the International Network on Soil Pollution, INSOP. And that's basically a network to try to gather all the information about soil pollution. So plastics is one element of it, but they're working in others. I've included the email address of Natalia Rodriguez Eugenio. She works for the GSP. And if you're interested in engaging with them, go on the website, have a look, and then send an email to her. So that's my last slide. So thank you very much for your attention. I would be very happy to take questions. I don't know whether you want that to be done now or we'd leave them to the end. Okay, so we'll leave them to the end. So thank you, and thanks for your attention. Bye.
Thank you very much for that great introduction, putting it into context, the global headlines and the path forward on the international agenda. We're very much looking forward to the conference in November.
And I would welcome Mr. Lemois would be the next speaker who's here in person. And then we would just go on with that and then try to fix this in the meantime. If you would like to share the presentation of Mr. Lemois, Martina, let me just hop over, and then apologies to Mr. in China. We will try to get this fixed in the meantime. Okay. Thank you.
Thank you very much for inviting me here in this specific academic event. I think all of us are concerned by the situation about accumulation of plastic in soil and microplastic. I totally agree with Richard when he's talking about the real need to improve the governance of plastic in agriculture all over the world. We have some space where some experiment and some experience has been accumulated and providing some key for answering to this question. Okay, so I'm supposed to be the bad guy here since I'm representing the industry, and I am very pleased to be with the research people, because we definitely need to work together to find solutions and provide solutions to the farmers, to the agricultural production, and of course for the environment. As I said, we are working for years in those topics in a very practical way, but we still need to increase the knowledge, the level of knowledge we could have about the damage or plastic or product may cause to the environment if they are not properly managed. So to give you a focus about the European situation, as was said before, the main focus on when we talk about plastic accumulation in soil is on mulching. And you need to know that mulching is around 83,000 tons in Europe, when we are using around 720,000 tons of plastic in Europe. There are different kinds of plastic: greenhouses, small tunnel, mulching, silage, stretch, twine, net, irrigation pipe. All those products are used for the agricultural production, but each one of them has a specific attitude in front of the end of life and their impact on the environment. Of course, no need to say that the biggest impact the plastic may have is with the mulching. We are dealing, by the way, only with a non-packaging plastic, which means plastic products directly linked to the agricultural production. We are not protecting as a packaging, and also with our product having an agronomic effect on the production, which means that without the usage of plastic, we will have a big drop in the production. We are talking about 60% of the production, and also a big increase in terms of cost, and big increase in terms of usage of arable land and so on. One thing we want to be clear is that our plastic is not contaminated by chemicals. We will find some trace maybe, but not contaminated by chemicals, even though we are using chemicals during the production. But our product may be highly soiled with organic, mineral, and water, but we don't treat that as contamination, as chemical contamination, because it is natural product. So in the sector, everybody knows that, but of course we need to bring evidence and scientific data on it, and we are working to make analysis about to underline this topic, and it is very, very important to have a good knowledge of that, because our products are not dangerous. As a matter of fact, they are not dangerous waste. Okay, so if we talk about mulching, we are talking about only, I will say, only 83,000 tons of plastic used in agriculture in Europe, besides those 720,000 tons used normally in agriculture, and besides the 55 million tons Europe is using every year in terms of plastic, all product combined. Okay, so the use of plastic is covering about 250,000 hectares, 1 or 2 seasons, depending on the crop and the practices. The fact is that when we are using 1 ton of mulching, we are collecting at the end of its useful life, we are collecting 1.2, 1.5, sometimes 3 tons of plastic, because of the soilage content, because of the mineral, the water, mainly water, as a matter of fact, and the organic matters. And this is one of the negative impacts, because if you talk about the neutrality, the carbon neutrality, I mean, you still need to collect this volume and to load it and to ship it to the final destination, which means that you will use a lot of trucks to do it. if the product would have been clean. So I'm not going to define again the interest of the use of plastic in agriculture. What is for sure that we definitely need to find the solution to avoid those negative impacts in the environment. You have some numbers about the situation in China, for instance. The problem is very, very important in it. I'm not going to talk about it because there is another speaker about the subject, but we just have identified exactly what is the situation. We have to say for the industry that the biodegradable product is a part of the solution. I mean, biodegradable product cannot replace all the plastic. What's funny, because I was talking the other day with the Ministry of the Agriculture in France, and they asked me why we couldn't change all the plastic and use only biodegradable products. Okay, so there is a misunderstanding about what is the biodegradable product, what are the applications possible on the biodegradable product, and there is also a misunderstanding about the end of life of those products. Okay, and this is very important to assess this problem to have the people comfortable with it. Bioassimilation within 44 months, 90% within 44 months. This is the standard. If you consider that we are putting 1,550 kilos per hectare of biodegradable product, which means that after 2 years, you have only 15 kilos left on the soil. And if you make the ratio between the soil, 300,000 tons, and 15 kilos, you'll see that the impact is very, very minor and even not necessarily negative. But we need to assess all that. The biodegradable products are not that easy to use. Okay, it depends upon the climate conditions, the soil condition. We need to have already an existing biomass in the soil, and we cannot expect miracle. But if we control all those aspects and if we are applying good practices, for sure, biodegradable products are part of the solution. So we have identified the weakness in terms of plastic accumulation. First, the plastic characteristic. When we talk about plastic having 8-9 micron gauge, I mean, it's for sure that after its useful life, we are not necessarily in position to remove 100% of the plastic out of the field. So the product characteristic is very important. For instance, we are having a gauge, minimum gauge in Europe of 20 micron in the standard. Probably we will go further than that. But in some other place and the product without standard, they can be lower than that, 15 or even lower, as it is in a cotton field in China with only 8 or 9 microns. So which means that we cannot remove 100% of the plastic in that condition. And this is probably one of the first actions we may have. Bad practices also is the reason for this impact in the environment. So we can say, well, we cannot necessarily condemn the farmers using bad practice. But if the farmers is not well trained, if the farmers is not informed about the reality, of course, he will use his own solution, and this solution will not be necessarily the good one. Okay. So one thing is for sure, we need to inform, we need a good pedagogy, and we need to provide with technical data and technical recommendation on the usage of the product. And the last point for us is the lack of collection system. If there is no organized collecting system, there is no sustainability, there is no solution for the farmers. The farmers is made to produce. The farmer is not made to manage waste. So we need to provide the farmers with solution, and only only collection system may provide the farmers with solution. So each time when we see accumulation of plastic in soil, you notice that there is a lack of collection system. Of course, no need to say how big is the damage of the plastic accumulation in soil, and by consequences, the microplastic is important, and we definitely need to fight about this to eradicate those bad practices. So first, we have a weapon with several bullets. So the increase of knowledge is probably the most important one, and thanks to you to work on that. We are very much welcoming this work, because we need to know a little bit better what's going on and what are exactly the impact. We need to change the product characteristic and abandon the thin film, and probably this is mandatory, and we will push that solution in the evolution of the standard in Europe. Those evolution are on the way with the working group 2026, where we are going to put best practices. We are going to put end-of-life management of the plastic. Also, our objective being zero plastic on field, 100% recycled. Of course, we need to disseminate the good practices. We know the good practices. The problem that they are not enough disseminated everywhere, and probably the academic work you are doing is probably a good vector also to disseminate those good practices. We need to put money on research and development. I just want to give you an example. We have developed the refuse system in France. The refuse system is made to clean the film during the removing operation. Okay, we got good results with that, since the solid content was reduced by 3 or 4, which means a big change, allowing the product to be recycled. Otherwise, it is not recyclable, or at least too expensive to be recycled, and then going to the landfill. And we know that we don't want any plastic in the landfill either. R&D is important. R&D also is important for the use of biodegradable. Then we have the development of national collection scheme. We are deeply involved in it. The industry is deeply involved in it. We are able to provide technical solutions, to provide economical solutions. In that sense, this is where we need a change in the governance, to improve the governance of it, and to have all the stakeholders together fixing the problem of the end of life of the plastic we are using in agriculture. When I say all stakeholders, talking about the farmers and growers, of course, but also the distribution and the industry. So the only message I can make is that, yes, the industry is committed to fix all those problems. Yes, the industry is willing to increase the knowledge. The industry is also willing to collaborate and to provide the academic sector with all the knowledge we have accumulated over the years. And we are sure that all together we can find the best technical and economic solution for not necessarily for the industry, but for the agricultural production, where plastic is just a need. We cannot do without plastic anymore. But we want to make sure that everything is clean after the usage of plastic, and with no damage for the environment. We are committed not only in the national collection scheme or in research and so on, but we are committed in several products like Clean Sweep, Marine Litter, the national collection scheme development, the Circular Plastic Alliance, and we did establish a European Plasticulture strategy and European Plasticulture Alliance to make sure that we can share all these concerns with the largest community as possible. In fact, In fact, we are calling for a global extended producer responsibility, where the extended producer responsibility is not only made to finance the collection, but to manage the complete process during the whole chain, from the conception, the production, the usage, the collection, the recycling, and the integration. We are calling for global extended producer responsibility. And in that sense, you can depend on industry being an adult on that. Of course, things are never going fast enough. Okay, we need to speed the process. We need to increase our knowledge, and we need collaboration as Papillon and MINAGRIS to convince and to accelerate the process to make a better agricultural production in a safer environment. Thank you very much.
Thank you very much on these words. It was a pleasure to hear a bit on the European perspective, as well as to receive some focus on the mulching film. Moreover, that the farmers were mentioned, and farmers need knowledge as well to make sure that they can contribute to the solution. Finally, I would just like to point out and thank you for the willingness of the industry. The Papillons and the MINAGRIS project is both a multi-actor approach project, so we are very keen to indeed try to deepen these cooperations and understanding between both of us. While this is being set up, I'll just say furthermore that at the same time, we're very happy to see that there are national initiatives as well, such as in France, to see that it is being discussed in these levels as well. And finally, to put in your words, now after the bad guy, perhaps we can see the good guy, but it wasn't my parallel. I'm just paraphrasing you, if I'm not mistaken. So I would like to ask Ms. Sophie Wong to come to the floor, who is from the Plastic Soup Foundation, and her research is focused exactly on microplastics as well and plastic additives. And I would like to now give the floor to you. Thank you very much.
Thank you. Good morning, everyone. It's a great pleasure to be here and for being given the opportunity to present the NGO perspective on plasticulture. And I'd like to start with a disturbing fact, which is that globally 52% of soils are currently degraded, and in Europe 60 to 70% of soils are considered unhealthy. However, life depends on healthy soils, and soils are being threatened by various stressors, including climate change, pesticide use, but of course also plastics. And various NGOs have addressed this issue over the past year. For example, Toxiflink, an Indian-based NGO working on plastic mulching and the effects and the microplastic pollution caused by this agricultural practice, as well as the Center of International Environmental Law, focusing on agrochemicals and the intentional use of microplastics in these products. And we as Plastic Soup Foundation have also called attention to this topic during the second Plastic Health Summit, which we held in Amsterdam in October of 2021, during which Dr. Esperanza Huerta Luanga, who will also be speaking today, spoke about microplastics affecting crop growth, soil quality, and also how this is affecting food safety. Because as we heard this morning, crops can take up microplastics and nanoplastics, and this creates an exposure pathway to humans to microplastics and nanoplastics. Also, the Environmental Investigation Agency has given attention to this topic and created a beautifully yet disturbing video showing that plastic pollution of agricultural soils is not the only issue here, but that agri-plastics create a huge waste issue and also severe environmental damage. And unfortunately, I cannot show the entire video here due to time constraints, but I invite everyone to watch this really beautifully made video. And of course, we've heard also this morning that agri-plastics provide many benefits to farmers, but the short-term gains do not outweigh the long-term damage. these agri-plastics, they put soil quality and resilience at risk, jeopardizing food safety and security in the long run, and we feel urgent action is required. We thus very much welcome the report by the FAO, serving as a loud call to coordinated and decisive action to facilitate good management practices and curb disastrous use, that's the word that was used, of plastics across the agricultural sectors. And I'm very happy and pleased that we got the chance to hear the presentation this morning. And in my talk, I'd like to draw specific attention to the use of biodegradable polymers, which has also been mentioned briefly. Biodegradable polymers are being proposed as substitutes to conventional plastics in two very high-risk products in agriculture, which are inorganic fertilizers and agricultural mulch films. And these polymers are designed to be broken down by microorganisms, so they should not be contributing to microplastic pollution in the soil. However, this has been, whether this is truly the case, has been argued or questioned by the NGO community, but also the scientific community, because the underlying standard assessing biodegradability of plastics in soil has many limitations. It's been argued, for example, that the test conditions poorly reflect the various environmental and climatic conditions present across the EU. Testing is done at approximately 25 degrees Celsius, humid and oxygen-rich conditions, and these conditions are very favorable for microbial activity and thus also for biodegradation. However, of course, these conditions are often not present across the EU. For example, in northern regions where it's much colder, or in the Mediterranean where very arid conditions are present. Also in this standard, just one soil type is used, whereas soils across Europe vary widely. And another limitation of this standard is that other environmental compartments are not included. While it's known that microplastics can move between different compartments. So for example, they can move from soil to the aquatic systems. And lastly, testing is done with powder form rather than with the intact material, which will increase the surface area of the material to be biodegraded, which will likely lead to higher biodegradation rates than when intact film would have been used. And for this reason, various concerns exist that biodegradable polymers can persist in certain environments over long time scales. And this has actually been, this concern has been confirmed to be valid, because experimental field research showed that the degradation of plastic mulch films is much slower in colder and arid conditions. So we at Plasticulture Foundation are quite concerned that these materials can persist in the environment for a much longer time than is presumed by these standardized tests. And that is why we decided to do a research project in collaboration with Wageningen University in the Netherlands to investigate to what extent these materials contribute to microplastic pollution in soil. We're currently visiting growers and farmers in different climates, taking soil samples, but also water samples of the surrounding water to assess whether accumulation of microplastics is taking place in soil and aquatic systems. And with regards to these biodegradable polymers, we wish to present a few policy recommendations. We feel that while these knowledge gaps regarding the persistency, but also the toxicity of materials are still lacking, the precautionary principles should be adopted. For example, at the moment, in the European Commission's draft proposal on the intentional use of microplastics in agricultural products, or among others agricultural products, biodegradable polymers are derogated, and we strongly oppose this decision. Moreover, we feel that current standardized biodegradability tests should be revised to represent a range of environmental and climatic conditions. Yet even with these revisions, these standardized tests will always present an oversimplification of real-world conditions, and we therefore feel that laboratory microcosm and field experiments should be conducted to calibrate these standards. Unfortunately, we're seeing that the European Union is also acknowledging the severe problems in the agricultural sector and wishes to transition to more sustainable agri-food systems. And they've done this by developing several very ambitious strategies in which they promote organic farming, for example, and the reduction of pesticide use and inorganic fertilizer use. And such high ambitions are very urgently needed, but right now it seems that agri-plastics are falling through the policy cracks. Although this microplastic restriction is underway, biodegradable polymers might be derogated, and the environmental gain of this restriction is therefore still very uncertain. Also, in the initiative to reduce the unintentional release of microplastics, geotextiles have been included as a product, whereas plastic mulch films and sludge application have not, while these are known to contribute to high plastic pollution in soils. So we call actually upon the European Union to tackle this issue and strongly regulate the use of agri-plastics. For this, we wish to give a few policy recommendations, which are improved record keeping of agri-plastic use through mandatory national reporting of agri-plastics placed on the market, improved end-of-life management through mandatory extended producer responsibility schemes and improved collection and treatment, an adequate enforcement of a ban on open burning, a ban on the intentional use of microplastics, including biodegradable synthetic polymers, and acknowledging the geographic differences across Europe, because local and regional needs will vary, and policies should be tailored to these specific conditions. And throughout this process, primary stakeholders such as farmers and growers should also be included. Also, we feel that refuse, redesign, and reuse should always be the priority over recover, recycle, and reuse. That policy should be harmonized with existing policies, regulatory frameworks, and ambitions. The policies must always be science-based, and that research and innovation should be promoted for the development of non-toxic and non-persistent materials. Also, we feel that policy should facilitate a transition to agri-food systems that do not require the extensive use of pesticides, inorganic fertilizers, and agri-plastics. But of course, the issue of agri-plastics reaches far beyond the European borders, and tackling this issue on a global level will be even more challenging. Also, again, policies and actions should be assessed based on a local and regional level, depending on the agricultural practices, the agri-plastic usage, and climate. And we support many of the recommendations that have been given by the Food and Agriculture Organization, which are the development and rapid implementation of a comprehensive voluntary code of conduct covering all agri-plastics, extending the scope of existing international conventions, including the Basel and Marpol conventions, and a new international convention on all plastics, including agri-plastics. Yet we also recognize that some of these measures might be very difficult to implement, for example, because infrastructure is lacked to collect and treat plastic waste is lacking in many parts of the world. So financial and technical aid to support states that lack the means to implement these necessary measures would contribute strongly to tackling this issue on a global level. And this actually has been proposed in the draft resolution of the Global Treaty, stating the need for capacity building and technical and financial assistance in order to be effectively implemented by developing countries and countries with economies in transition. And we are very hopeful that this will be included. Unfortunately, this is a very complex issue and there's no silver bullet solution. And I'm really looking forward to speaking to all the involved stakeholders today and discussing how we can curb the environmental pollution caused by agri-plastics. Thank you.
First of all, here we are a scientific forum. We are not a political forum. So first of all, we cannot accept facts that are not scientifically wrong, and we cannot accept also solutions. We have a real problem that we have to solve. We cannot say stop everything. We have to find a solution to solve the problem that exists. We cannot say not. The solution actually doesn't work. We have to do something. We cannot say stop everything.
Yes, I absolutely agree with you.
But you did not agree according to your facts or your
We we can take this debate later on because.
Yeah, but you cannot accept non-scientific facts.
Okay.
So, we are scientific here.
I'd love to discuss this later.
We can take it later because.
Yes.
And of course, there will be chance of discussion, but if we start digging into the scientific evidences now, we go on 2 hours. But we have time later.
Wrong things, wrong states.
We discuss. We will have time to discuss later today. So a little bit of patience. So shall we move on?
Well, thank you very much for the presentation. I do believe we have some stakeholders and policymakers online from the various commission DGs, so I think they have heard it as well, the message. And within the PAPILLONS consortium, I can reassure you that there is a working package just dedicated to the plants topic and issues. Finally, speaking of your video, I think if all of our presentators agree, then we can upload their presentations to our website as well and distribute it on the MINAGRIS website as well, so they can further see them. But now moving on, because so far each speaker has spoken a bit about farmers, we would like to give the floor to one of the farming organizations being present here in Greece. We have 2 speakers, so who I would like to invite to the floor, Maria Cora and Angeliki Lagociani. Sorry, my Greek hasn't been very fluent recently, but I would like to give now the floor to you as a local farming perspective. Thank you very much.
Good morning, everybody. Thank you for the invitation. I'm Maria Corre. My colleague Angeliki Lagociani and I are here on behalf of the IKHAPP. IKHAPP is the key supporting entity of Greek farmers and agri-cooperatives, providing information, services, policy support in order to become more sustainable and competitive, while making the most out of European Union and national financial tools. IKHAPP aims today to present farmers' point of view, but first of all, let's say a few things about the current situation in Greece. It is widely known that the problem of plastic solution in Greece agriculture is linked not only to the large quantities of plastics that are used, but also to the dominant management practices, which are land disposal and burning. In Greece, recording of produced and used quantities of plastic is deficient. Quantifying the plastic used in agriculture is the first step, while a waste plastic management and recycling system should be used all over the country. It is important to note that in Greece does not exist an entity to organize and to coordinate the collecting and recycling of agricultural plastics, nor to create a procedure to label all agricultural waste streams. For example, to this day, pilot programs that aims to build a collection system for pesticide containers have been implemented only by some municipalities and the Greek Association for Plant Protection. And in addition to all this, farmers need further training. That will be a key element for a successful agricultural waste management system regarding plastics.
Hello to everyone. I'm Angeliki Lagociani from the IKHAPP, and I will present here the farmer's point of view, the farmer's needs. Farmers are willing to try to properly manage their plastic waste and reduce the use of plastics in agriculture. However, farmers need more guidance. Farmers state that they are not properly informed regarding the innovative alternatives to plastics used in agriculture. Farmers want to be trained on how to develop a set of good farm practices to reduce, reuse, recycle plastics, and the solutions proposed by the farmers. farmers need an easy-to-implement regulatory framework. We should keep in mind that farmers do not have a regular work week. They work on holidays, they work under difficult conditions, so a time-consuming, a complex procedure will help them recycle. Farmers also need agricultural consultants. Consultants can help farmers to have the advice that they need in order to recycle better. Farmers also should participate in collective teams, such as producer organizations, to gain knowledge, to gain from the training tools of such collective teams. And to end up with, dissemination is a key element. Project results such as MINAGRIS and the PAPILLONs project results should be widely disseminated to all the interested parties. Also, influencers should be used, and the traditional communication channels, and also the sales channels and the field trainings. In conclusion, farmers state that the combined effort that involves agricultural consultants will train and inform farmers, and an easy-to-implement regulatory framework should take place in order to reduce the negative effects of plastics in agriculture. Thank you very much for your attention.
Thank you very much to the both of you for showing us a bit that at the end of the day, it is the farmers that need to be able to do the hard work. And in order to do so, they need solutions which can apply as an end user. Now we will retry again with our speakers who are online. And I do believe we have the presentation of Pierre Leponieux in front of us. So if you have the opportunity, could you please talk?
Just want to give this another trial before we try for plan B, but you want to try to speak?
Yeah, do you hear me?
Yes, we
Perfect.
do. Beautiful.
Do you see me? Not sure. I think I have. Yeah. Okay, so ladies and gentlemen, good morning. It's a great honor for me to present you the feedback from our French agri-plastic waste management initiative. I would like to thank Papillon and MINAGRIS for inviting me, and special thanks for the organization. My name is Pierre Leponieux. I am an agricultural engineer with over 20 years of expertise in waste management and plastic recycling in France and abroad. I was the general manager of Adivalor since its creation in here in the video in 2001, and now I'm moving to a position of independent expert. I'm still bringing technical support to Adivalor, but now I'm going to create my own consultant company called ERA Consulting. Coming back to Adivalor, who are we? How does it work? The key stakeholders of our national schemes are farmers, collection operators, and marketers. Marketers meaning manufacturers and importers. Our action is supported by the chambers of agriculture and farmers unions. Adivalor is a non-for-profit eco-organization. This is a private company, but non-profit, set up in 2001. We reached last year 23 million euro turnover with 21 employees. What is very important is that our governance, our shareholders are interprofessional. That means we have both on the board manufacturers, majority for the manufacturers, distributors, including cooperatives and private distributors, and farmers. Our raison d'être is to promote the responsible commitment of agri-suppliers and to help French agriculture to improve its environmental performance and competitiveness. Our vision is to reach zero waste in the field. How does it work? Our scheme was built on shared responsibility principle. That means that we ask farmers to sort, to prepare, and to drop their waste to collection point. These collection points are mainly managed by distributors. They have to check the drop of farmers, and they have to store before collection by a waste company, which are managed by Adivalor itself. Then the waste are sent to pre-treatment platforms. Most of the time they are baled and then sent to recyclers. We have implemented multi-year contracts with all the stakeholders in order to make the scheme sustainable. Here are our driving principles. I already explained the interprofessional governance, the shared responsibilities. The other point is that we achieve a national technical setup, but we let the organization of collection to be decided on local level. It helps, and it helps to make things more flexible and more convenient with farmers' need. Our scheme is not for profit, very transparent. That means we published every year our accounts, our results, and we have data exchange with public authorities. And last but not least, cost effectiveness. We have to bring a service, but as cheap as possible, in order to make to support farmers and to help them to remain competitive. So how does it work? On a financial point of view, you can see the red arrow on the chart. The manufacturers and other suppliers are paying an eco fee to their national association in France called CPA, Comité Français des Plastiques en Agriculture. The Manufacturers Association contract has implemented a multi-year contract with Adivalor, and Adivalor will order all the operation from the collection service until the recycling. As I explained before, we implement the scheme 20 years ago, more than 20 years ago. We start with plastic, agri-plastic in 2007. And here are the results. The collection rate is in blue, and you can see that we are now over 75% of collection rate after 15 years of development. And we have a recycling rate, very high one, due to the fact that we ask farmers to sort the different kind of waste, and that means we have monomaterials which could be, on a technical point of view, 100% recycled. Our challenge and our vision is to reach 100% collection rate and 100% recycling rate in 2030. As you can see on the chart, we have to face two specific problems with the recycling of mulching film. We have lost one plant who was able in the past to recycle, and then we will see we are supporting the creation of a new plant. Our EPR scheme can be called voluntary scheme with a contract with the government. When the French Act against waste and for circular economy has been published in 2020, The 62nd article said an organization that fulfills the extended responsibility obligation of producers in the agricultural supply sector, in accordance with an agreement concluded with the ministry responsible for the environment, is not subject to approval as long as this agreement is renewed. We have signed last year the 4th agreement with the Ministry of Environment in France. It helps to make things much more flexible, to fit closer to the agricultural needs and specificity. And the fact is that the system is, the scheme is running quite well. We enlarge the scope of the national scheme. We start with the plastic containers of pesticides, then plastic containers, bulk containers for fertilizers, and start plastic film in 2009, not 2007, as I said before, sorry. And we are still enlarging the scope of the scheme. For instance, we launch a new program of collection for flexible irrigation pipe on 2019. Mutualized management of the different types of waste help to get synergy, increase the expertise of our staff, and help to get economy of scale. It's important to underline that the key success of factor is to sensibilize all the farmers. And thanks to only one organization, we have to run only one single communication plan towards farmers, much more efficient, without any risk of mitigation due to various messages addressed by several national collection schemes. Here are key figures. We estimate that we have 116,000 tons of waste to recover, mainly plastic, agri-plastic. We reach average collection rate of 77%, but depending the age of the program, for instance, for pesticide containers, we are over 90%, 95% for fertilizer bulk containers, but only 37% for twines. We launched a program of collection for twines only 7 years ago. That means we collected last year 89,000 tons, and 90% of these waste were recycled, excepting mulching film. I will come back to this point. We transport over more than 1.3 cubic meters. That means a collection scheme is a huge logistic challenge. We are supporting the creation of new recycling units for the next 2 years. And let's focus on the new recycling unit for especially dedicated to mulching film, which should start beginning of next year. The company called Plasticulture. We support this company in close cooperation with National Plastic Industry Association. That means with this new plant, we intend to recycle 100% of all plastic, including mulching film. As you can see on this slide, we have also a project for bale net and twines, big bags, that mean flexible bulk containers used for seeds and fertilizer, and a new plant for stretch film. We have not enough capacities in France to recycle all the material, so until now we have to send the material in other EU countries. We have other key challenge next year in close cooperation with the National Plastic Industry Association. Will be launched an eco-modulation system. That means the eco fee paid by the manufacturers will could be reduced, especially if you use some recyclates, and of course, if the product is 100% recyclable. So it will help to improve eco-design, and eco-design is a key challenge in order to recycle all the material. The other challenge is still to enlarge the scope of collection. We are working on pilots for the collection and recycling of insect-proof nets, non-woven films, and other irrigation pipes. These are not big quantities, but our vision is to collect 100% of all agri-plastic. So thank you for your attention. Let's think circular when we are talking about agri-plastic. If you need more information, you can see the English web pages of Adivala website, and you can join me if you need additional info. Thank you very much. I hope my presentation has been useful.
Thank you very much. I hope you heard the applause as well from the room for your presentation. It was very nice to see initiatives that are progressing and targets and objectives, which are very nice to see. Furthermore, now we'll move to our next speaker, but I would like to ask you as well to stay online, as we will have some Q&A later on. Our next speaker is Mr. Dahuhe, who is here with us from China. So we would like to give him the floor to give the Chinese perspective and the ongoing research that is taking place there. Can you hear us?
Hello, everyone. Can you hear clear?
Yes, crystal clear. You may go ahead.
Thank you. Very glad to see you online. I'm in Shanghai. Thanks to the invitation of Lucy. My speaker title is Microplastic Pollution in Agriculture, so in China. I'm therefore from the Shanghai in Eastern China Normal University.
Sorry, there must be something in the background making some noise.
Okay. Okay. Some. Yeah. So my speaker containing 4 aspects: background, agricultural, soil, plastic pollution, China's controls policy. So the key background of the soil plastic pollution is a big change from the natural farm to the plastic culture, also the facility agriculture in China. So these including the loose house, shed, and material. So some voice, sorry. So the China's plastic production total like this picture. So the total constitutes about 30% of the total world's plastic. So it's a big increase in the recent 20 years at this.
Sorry, I just interrupt you. I just want to let you know this is background noise. Back is a long way from China.
So you can find the agricultural plastic film in China also is increased about 2 million tons every year. So at the same time, the application of the agricultural film used are not even in China, with high in the northwest, the Zhuo province, including Xinjiang, Gansu, and also in the eastern part. So here they show some picture very common in our cereal in Gansu, Hubei, Ningxia province. So how about the plastic film received in the farmland? So we, sorry. So we, this is a nationwide field survey and it says more than 700 sites across China. So this degrees result. So the level, highest pollution level, you can find the pollution level is related to the manufacturers, including the farmers' effort, crop type, market time. How about the pollution of the microplastic? You know, the microplastics have more severe risk or the devices, effectors, and big plastic residue. So the effect of the several study about the local scale study in China, given the press and the abundance, the result is very different. So this is very high. This is low. How about the natural scale distribution of the microplastic in the farm soils? So especially use the same method or the consistent same method. You know, different method result is different result. So we did this work across China in the 2019. We sample soils from 30 big market farmer site. So this shows the picture. We sample the place. So many much used in the farm. This shows the result. So all sites found the microplastic. According to the microplastic number, this is the range of the abundance. The meaning about 300 times per kg. Across the nation, this is the highest evidence in the west, north part and east part, but low in the southwest part. This is warm and there's a wetter climate. This place, the different say, but the total mass plastic only account about 6% of the total. So we more consider the mass concentration of the microplastic. So we will work as the conversion from the volume to into the mass. So you can see this result. The total mass concentration is about this result, 0.0007%. If the consider the total plastic, including micro, meso, and macroplastic, so you can see this result. So across the family site, there is a relationship like this. But the total concentration is this range. The mean is about the 0.01545%. About the shape, microplastic shape, you can see the most is the fragment and the fiber. This is the shape and the identification result. About microplastic size, also the small, less than this 3 micrometer. It's most and different in the soil lay and fragment shape, the microplastic shape different. The preliminary type about the 5 types, and the most is PP and P and PS. So this is the PPP and PS, and the fragment is PP, and the fiber is PP and the PS, and the film is most is P. So how about the environmental risk of the current microplastic level in the farmland soils? So this is a big and hard to answer the question. You know, the current study about the soils microplastic most in the 2 aspects. One is feed, like this feeders assay research, and another is labeled conditional simulator exposure study. So based on this, we have done a method analysis about 26 study of the simulator explosion of microplastic in soils, about 6 implement, but then the WSA, FDSE, and US, and the global biomass. So that didn't work. So this result, you can find the effect size is different among the subtype and the shape and the size. So show the effect where's among the microplastic shape and size. This is no many time to talk about this result. And show the avoids concentration effect relationship between the microplastic and the effect size. We finally we account the minimum effective concentration of the microplastic. This is the range, and the middle weighs about 0.5%. But the accurate concentration is this range, and there is a significant difference. This high, this low. So it implies the relative environmental risk of the microplastic is low, but long-term ecological environmental risk should be pay attention to. The last is about the confirmation of the soils microplastic governance in China. So, in fact, there's a lot of the national law and regulation about this. This shows some important law and regulations like this, especially in the recent 5 to 10 years. Many law and regulation are open to the public. So especially about the soils microplastic and agricultural soils microplastic control, and the recycle ecological film, and encourage use bio-based plastic products, and the recycled lead, etc. The aim use the biodegradable mulch. Also limit the plastic film thickness. So, and this is 2 law. One is the soils pollution control law, and this is solid waste pollution control law. In the last year, the action of the 5 years plan on the control plastic pollution is open to the public. This is the result. So it's very important to guide the pollution governance. So the key point is improve the whole chain of the plastic pollution control system, including the production, distribution, consumption, and recycle and resorption. And the detail may including the carbon production and use of soil plastics, soil plastics, and develop alternatives of the plastic, and reduce the amount of plastic waste with the clean and other mess. About the soil microplastic pollution governance, this action plan set 85% recycle rate and zero growth of the mature residue, and now beginning to monitor the microplastics in the farm soils. So popularizing and use of the biodegradable plastic film. So use last the summer my speaker. So there is national scan pollution of microplastic in the farm soil in China. Some places very serious, and there are remarkable impact of the microplastic on the soil's property and global, like this picture in our publication. Factor the soil's property and the below maybe uptake and effect of the soil's animal use impact of the soil's health. So the pollution is on the road. So about the microplastic pollution, the control research in China. So there is a big community, research community, and several the project, big project, and a lot of the team and research this, and also publication, including the special book. So that's all. Thank you, listening. Thank you very much. This is my group in the microplastic research group in our university. That's all. Thank you. Very sorry, there's some voice.
I'll unmute you if it's possible. Thank you very much for showing a different perspective and underlying that it's a global issue and research is being done on multiple ends of the globe. Now we can even see you on the screen. We just waved, and we would like to make sure that we can continue such cooperations and deepening of understanding the issues. And now on our international road trip, we will go to another presentation from Miss Christina Reigessen. I hope she's here with us and can hear.
Now I'm here. Sorry for the delay before. Should I share my presentation from here?
Yes, that would be wonderful. And now we can see it crystal clear.
No, that was good. Okay.
Thank you.
So, thank you for being patient to actually letting me log on. Took some time. Sorry about that. I had some time issues. So, Grid Arendal, based in Norway. My name is Christina Tygesen. I'm really delighted to be here. I'm very delighted for the last presentation as well, about all the local data from China. So Grid is a UNEP partner. We are a few people working there, and most of what we do is science-based. So we take all the science that you guys do and we massage it and we put it into communication products. We try to look at the positive side where we can do change, and we also try to do policy briefs to inform people about, to inform policies about how to change things. So we started this work in 2021, where we looked at agriculture for the first time as a source to sea concept. So all the plastic coming from agricultural land going into the sea. And it was presented in From Pollution to Solution, which came out from UNEP in 2021. After that, we made our own dedicated publication. And you see it here, plastic in agriculture, sources and impact. And with that one, we were interested in increasing knowledge. We wanted to invite for discussion, and we wanted to look at actions that we could do with relevant stakeholders to reduce this plastic contamination of soil. It has been followed in 2022 by a unit foresight brief, where we also talk about plastic and microplastic, especially in soil, and ways to avoid it and mitigate it maybe. And then we also have a web story where we can't look at fashion and microplastic in sewage sludge, which is also a problem. So this is a picture that I really like because it actually shows us what's going on, and I'm sure that most of you have seen it before and can see that there is an issue here if we continue the way we do. Another thing we have been looking at is this plastic accumulation in soil, of course. And when we try to do these communication products, we use information from around the world. And we see here that we have a lot from Asia. We don't have too much from the States, nor for South America. And we do have something in Europe. So what we really would like to see here, and that is one of our first recommendations or suggestions, is that we really need to find a good sample methods and find the standard for how we do sampling and how we look at the sites that we do the sampling, because you see we get the information in different kind of units, which is a challenge for us when we have to communicate it. So in this publication, we also looked at the different sources, and I'm just going to present two of them here to show how we communicate it. So the first one was the plastic mulch film, and we know that it has huge amount of benefits and it's really good for farmers, and we also know that there are a huge amount of challenges with it. And I'm getting something here. Are you actually seeing my screen when I change it? Yes, you are. And I was happy to hear about the French initiative, because we also have huge challenges when we want to recycle it. And what this graphic shows here is the amount of contamination that are, for example, with mulching here, that it increased 200% in weight. And we also looked into the biodegradable mulch plastic and found that there were issues with that as well, as you know. And as the Plastic Soup Foundation came up with. So basically, we have a challenge with the robustness, the fact that you plow it down and people see it, the fact that we have raw material that still might be from hydrocarbons, and we still do not understand the actual aspects of upscaling this issue. So is this really an alternative? I think that's quite important for policymakers to know. Then we have another issue that we have dived into, which is this one over here, which is the sewage sludge for biosolids fertilizer. And if we look at how we use the sewage sludge around the world, we see that a lot of it actually falls within agriculture. So we have a challenge here that we need to address. And of course, there are methods to actually, you can burn it and get rid of the microplastic, but it still ends up in our soils. And that's why we try to do communications like this one, where we talk about the connection between fast fashion and sewage sludge. And in here, we have presented how our textile market has turned from being actually pretty full of natural fibers to be more or less covered by synthetic fibers. And with that, our challenge become even more. And I think some of you know these numbers and have actually provided those numbers for us. And we'll see how many tons per year that we add to our soil. Another thing we do when we work with UNEB is we try to look for nature to find solutions. So what we call the nature positive solutions for food production, to really what can be regenerative, non-depleting and non-destructive. And here we would like to focus on what plastic products can be replaced by nature-based solutions. So what kind of cover crops can we use instead? So really look into what are the short-term and long-term benefits. Are there good upscaling solutions? And what is actually the economy in this? We would really like to look at the economical calculation behind using plastic and behind using more nature-based methods. So of this report came some recommendation. And as I said, the first is really to find standardized methods so we can get a baseline and better understand the residence time for these plastics. We would like to investigate the contribution of transported agricultural plastic into waterways and other ecosystems like the oceans. We would like to look at the soil contamination and crop yield. So how much plastic do we need to accumulate within the soil for actually seeing it's a problem for food safety? And then we have some other recommendations. Basically, we would like to test these new solutions better and find cost-effective plastic alternatives that we can use, and also maybe look at machinery that we can use for doing the plastic work. So these are basically like recommendations that we come up with, and we continue doing these small publications on plastic. And hopefully being a part of this research community here, we can get much more information about the plastic. So that was it for me. Thank you.
Thank you very much for your presentation and for underlying that we need sensibilization for a wider society as well in topics such as fashion and sewage sludge, for example, and the need for solid research. So this is going to be my point where I now give the floor to our twin sister project, the MINAGRIS project, represented by Ms. Esperanza Huerta Luanga from the Wageningen University. I hope she's here and can hear us. She is about to represent, as I said, the sister twin project that is being supported by the European Commission as well. They are doing similar research, however, their approach is a bit different. So I would like to ask her to present the project. Thank you very much.
Thank you very much. Good morning, everybody. Do you hear me well?
I hear you very well.
Okay, super. Then I will share my presentation. Okay, so indeed, thank you for the invitation. Thank you for being here to all the stakeholders. So I will share what we are doing in MINAGRIS. And they say to me that I need to be focused on plastic mulch. So that's why in my title, I have also plastic mulch. So what is the content of my presentation? Then I will talk briefly over plastic mulch use, then plastic mulch in MINAGRIS, macro and microplastics, and the risk assessment. Okay, plastic mulch uses. So you have seen this already. In different parts of the world, plastic mulch are used because they provide benefits. They help in the areas that are very. Do you still hear me? Or no? I
hear you.
Okay, perfect. So in the arid areas, yeah, that is used for having moisture. So different types of crops are growing here. In another areas, these photos are provided by, the first one was provided by Nicolas Beyrouat, this one by Luc Fols. This is in France. So the use of plastic mulch are so diverse. So there are mostly pumpkins are growing with plastic mulch, but also another kind. So this photo is very interesting because you see the agricultural area so nearby from the nature area. This is in France. Also, plastic mulch used inside greenhouses. So there is a big input of plastics, we can say. Another photo, so another kind of plastic mulch also nearby or interacting with natural areas or in another kind of environment. another photo here with pepper, and even that is an a polyculture, we can say, also with plastic molds. So plastic molds are used in different kind of environments, in different kind of crops, in organic crops, in conventional crops, in transition crops. So are widely used, and we have also a diversity of plastic mulch. So in agricultural areas, films, the plastic mulch constitute a big input of plastics in the soils, together with another kind of plastics, but the mulch films, are constituting a big percentage. Okay, so what we are trying to do in Minagris? Okay, so we have the idea is that's why it's very important the stakeholders are here together with us, because we want to find solutions together. Even though the plastic mulch is very innovative and is supporting solutions for agriculture in different areas, in different parts of the world, there is a production or emission of macro, meso, and microplastics, also nanoplastics. Already in previous presentations, it was also said and explained how these macro, meso, and microplastics are formed. So, but here in Minagris, so we want to understand from the beginning also when the plastic is made, the kind of additives that are also in the plastic, we want to understand that. So that's why we want that the industry be together with us. Those that are making the plastics can also open their books and say to us, okay, we use these products, and then maybe they are not harmful. We are not judging. We just want to understand. So we start here in the cycle from the industry, the production of the plastics, and then they are used in agriculture, as I showed in the photos. And then there is this degradation, the macro, meso, micro, and nanoplastics. And then these are degraded, and then they are transported. And then they made an influence on the soil ecosystem services, and of course on production. And the farmers are using them because they see that the plants are growing well. But even though we here in MINAGRIS, we try to understand what are the impacts of the plastic residues in soil at different levels, but we don't stay only in soil. So also we assess what is happening beyond. So in the groundwater, but also with the invertebrates that are interacting there. For instance, the bees. So we are going to also assess the soil health and how also the different biogeochemical aspects are influenced by plastic residues, by different kind of plastic residues. And then, of course, after having information, we want to share that and also to analyze in the socioeconomic dimension. Okay. So for that, we have 11 case study sites where we want to do all of these in each of these case study sites. And also we have experimental field stations. So once that we finish the sampling because we go to the agricultural areas at each case study site, we have 20 fields to assess, and there we assess macroplastics and also microplastics. And then in laboratory, we are going to install experiments. We just had last week our plenary meeting, and we are always in the same channel to do our experiments. And we are going to have also field experiments in the experimental field station. So those that have yellow are going to be our experimental field stations. So here I just show a photo that I took from our website. So I invite you also to go to the website of MINAGRIS. There are new things there. You also can inscribe yourself in the newsletter. These websites are managed by our colleagues from University of Gloucester. Okay, and then we are here in this level now, taking samples. Most of the case study sites leaders have already taken those samples and sent to the respective laboratories of us. For instance, one of is here in Wageningen University with us. So to assess the macroplastics and microplastics. Okay, macro and microplastics. So briefly, here I'm going to, okay, how these macro and microplastics are formed. It is already explained by my previous, by the previous presenters. So I'm not going to go deep on that, but just to see, if we do a zoom of the plastic molds, we can see that these plastic molds are very different, of course. And then, yeah, of course, plastics, microplastics are produced in different ways, but is from bigger particles to small particles. And then I hope you're seeing this. Yeah, and then those particles that are smaller than 5 millimeters are named microplastics. So this is like this that go the chain. So from the emission of plastic residues, these are fragmented by the action of air, water, and we all know that. So, and then we have these particles that are mixed with the aggregates of the soil, and then we have this different, also a diversity of microplastics. We have already in another projects assessed, and we can find around 11 different types of plastics in the soil. Okay, so here also close-ups of macroplastics. It is not nice, but yeah, the objective of this stakeholder meeting is to be also aware of the situation. So this is what we see on the fields when we are trying to sample different kinds of samples. Of course, it is not the same in all places, that changes from different areas, of course. Okay, risk assessment. Okay, so here I'm going to be more time just to explain. Okay, so here in MINAGRIS, as I said, okay, we are going to sample. So we are taking samples now, and we are analyzing the soil samples. We are going to have experiments, as I mentioned. This is done in work package 4, 5, and 6 of our project. Lab experiments, pot experiments. So without plants, with plants, we see what is happening. We are going to have these field experiments, as I mentioned, but yeah, and then see all the interactions at different levels: biological impacts, physical impact, chemical impact in the soil, and of course on plants. And this is done in the case study sites, as I mentioned. So we have also developed a method of standardization. This is one of the deliverables that I'm not going to show now here, but please, I invite you to go to the website of MINAGRIS. There we have, it's a public deliverable, so you can have access to that. And we standardize that because, as already said in Christina from the previous presentation, we need a method to assess these plastics. Of course, we have already, but we have several methods. So we needed to standardize, and so we did that in our project in MINAGRIS. And okay, so as I mentioned, he's analyzing pot experiment, field experiment. And then by the other side, analysis of the practices. So also this is very important. We have done interviews to the farmers because this is not possible if we don't have the help of the farmers. I hope that in the audience are also farmers. Well, this is true, or this is in the high level stakeholders. So those persons interacting with farmers, yes. So yeah, the plastics practices, and then we do a socioeconomical analysis and the work package 3 and 7 of the project. So we analyze the fate of degradation, the impact of of these plastics. We need to learn, or we are learning together with different stakeholders, how to deal with this problem. And of course, once that we have this knowledge, we want to give recommendations for the policymakers. Okay, so this photo is more in the side of the risk assessment. So once that the plastics are in soil, it is not static, it moves. So for instance, in those areas where there are vertebrates, they ingest these plastics also. So another photo to also, to make awareness of the risk assessment. So we have here the plastic particles in the left side of your slide, and then on the right side, we have an earthworm. Why is this? Because if there are plastics, these plastics, as I mentioned, are not static, they fragmented, they go inside, and then the invertebrates also take those particles and they move it along the tunnels that are inside of the soil. And then, as I showed, vertebrates can eat these invertebrates, and then at the end of the day, the humans are also infested. Okay, here, this diagram can explain better. So we have the emission of plastics. Well, the plastics biodegradable or not biodegradable. So the particles go at different ways. They are used here like a plastic mulch, for instance. So they are fragmented, degraded, and then they are dispersed. They remain in the soil. So in those areas that have more than 20 years or 15 years using plastic particles, so they are there. With the rain, these particles are run, are emitted, are moved into the water, in the water bodies that can be in the dikes, or that can be in all these water bodies that are nearby the agricultural areas. So there is transport of these plastics. And of course, also there is this infiltration. Also, these particles can move with the air. We have nice papers showing that how this, so we are also trying to understand this in MINAGRIS. And these particles are interacting with the plants and also with the soil invertebrates, like is in this diagram. So different soil invertebrates are trying to deal with these plastic particles, adapting to the situation, or if they don't adapt, they die, they extinct. So in the left side of this diagram, you can see also, well, invertebrates trying to deal with these plastic particles. So they transport it to deeper layers, that are mixed with aggregates, and other invertebrates just move it from one side to another, and that's it. So we are trying to understand all these phenomena at lab and field scale. And of course, communication. Communication is very important. And also Christina mentioned that in the previous presenter. So also here in MINAGRIS, we try to communicate. So we have an communication strategy, so to engage. So for instance, now we are doing this stakeholders meeting. It's very important because we want to engage, to work together to resolve this problem, because at the end of the day, all of us are affected with the plastic problematic, I mean, plastic pollution. Okay, so engage. And then after engaging, of course, sharing information. So it is very nice that Papillon and MINAGRIS, we are together working for finding these solutions and now communicating, exchange information, and after we produce results, and also we want to give recommendations to the policymakers. So this exchange can go also from industry to science and vice versa, and yeah, to those to take decisions. So this is what I have now. So thank you very much for your attention. This is a photo taken in Slovenia that we had our plenary meeting, and all these persons in the photo are members of the MINAGRIS project. So this is a teamwork. Yeah, thank you very much.
Thank you very much, Esperanza. Thank you for presenting the approach of MINAGRIS team, and that we were able to see that you could meet as well in person. It's very nice that we don't have to do everything online anymore. And I would like to thank the MINAGRIS project for their contribution to this event as well. As we have said, it's a joint event. So we would like to thank once again everyone involved in it to put it together finally, as well that you mentioned there's a cooperation ongoing between the two projects that we want to deepen. So we would like to ask the stakeholders to make sure to follow both programs, as it was said, and we can combine this way our impact and efforts. And for now, I would like to give the floor to some of our Papillon speakers. First of all, to Sam Van Loon from the Vrije Universiteit to present some of the mesocausal studies, maybe even preliminary results. You only know if you stay until the very end. Thank you.
Hi, good morning, everyone. My name is Tom, and I work for the Free University of Amsterdam. And today I'll talk to you a little bit about the microcosm studies that we do in Amsterdam. You see a picture of it here. The objective of these microcosm studies is to elucidate the processes and the factors controlling the behavior of the plastic and the effects of microplastic on soil properties, soil biodiversity, and on ecosystem services. So these mesocosm studies really complement the single species test we do. The single species test provides valuable information about what the effect is of these plastics on soil organisms. But using mesocosms with a reproduced or simplified ecosystem in them can really give us information about things we cannot see in single species tests, like changes in community structure. For instance, one organism gets the upper hand over other organisms. Soil physical chemical properties like changes in pH that we don't see in short-term single species tests, but we can see in long-term mesocosm tests. Changes in microbial parameters, effects on plants, and especially the interaction between these parameters. So, for instance, if the soil physical chemical properties change, then also the microbial activity might change and the plant performance might change. And these mesocosms really help show us these effects. And of course, they can help in environmental phase studies. So how does plastic move around in the soil column? And we can do this in a very controlled setting. So the system we use for this is called CLIMAX. It stands for Climatic Manipulation of Ecosystem Samples. This is a simplified picture of what it looks like. In this column, we can control pretty much everything. We can control the temperature of the soil separately from the air column above it. We can control the watering regime we have. We can collect lysates. It's a really nice system. Here you see a picture of it in action. During our first study, this first study was aimed at the effects of starch PBAT blend microplastics on soil organisms. We used Lufa 2.2 soil. That's a standard soil used in ecotoxicology. Because it's a natural soil, it has a natural microbiome and it better resembles the physical chemical properties of an agricultural soil. We used starch PBAT microplastics, and this effect study ran for 3 months. We used 3 different species of springtail. I included a picture because springtails aren't very famous, although they are found all over the world. This is a Protophrura fimata, one of the species used. It's about 1.5 millimeters long. We used 2 species of earthworm, and we used 2 species of plants, cress and lettuce. So some of the preliminary results really show the importance of using these mesocosm systems. Unfortunately, we're not at the stage that we can really present hard data, but we did see strong indications that the soil physical chemical properties are affected, for instance, the pH. We saw indications for a shift of microbial parameters, so nitrogen and carbon cycling, and we have indications that earthworm reproduction is affected and also plant performance is affected. Again, unfortunately, we're still in this phase of processing this data, which is a lot of work, so it's only preliminary. The upcoming mesocosm test will start next week when we come back from Athens, and it will focus on the fate of plastics in the soil column. So we included a larger soil column in which we have a clean soil layer of 30 centimeters and then a plow layer of 10 centimeters that has microplastics in it. And in this system, we can then see what the effect of the watering regime or the effect of earthworms on the displacement of these particles through the soil column is. And for this, we also did more improvements to CLIMAX, like for instance, a soil water content measurement that is now fully automated, and we can better control that as well. So in short, these mesocosms provide really good insight into processes that we cannot see in single species tests, and future tests will provide further insight in the fate and possibly also the more complex effects of microplastics in soil. Thank you.
Thank you very much, Sam, for these insights. And as you have said, the work is ongoing. You could hear next week, there will be even more to follow. And now to follow up comes Laura from the Leiden University. So we give the part of the ongoing work, which we would like to present and give the floor to our researchers. So please, the floor is yours, Laura.
Thank you. Hi, I'm Laura, and I'm from Leiden University, and today I'm going to talk about the effects of plastics on plants. So this is a relatively new field. That's why we started by looking at the research that has been done until this day. And what we identified is that most of the plants studied were lettuce, wheat, rice, and corn. Looking at the polymers that have been tested, the most have been on conventional plastics such as polystyrene and polyethylene. However, there's quite of a lack of studies for the biodegradable plastics. And also, when you look at how the plants were exposed to, it's been majority in pots or hydroponics, and there's a lack of studies in the field, for example. And within Papillon, we address these kind of research gaps. And our approach is basically to work in the first stage in the laboratory, looking at plant cell cultures, but also at single species tests, and then move on to more environmentally realistic conditions by working in the mesocosm as Sam presented, and also in the field. And today I'm going to focus on the single species test. So what we do, we took 2 monocots and 2 dicots. So here we use lettuce, carrot, wheat, and barley, and we expose them in the laboratory to pristine particles with polystyrene, but also weathered particle, the LLDPE, and also starch PBAT blend. And we do hydroponic experiments where we look at short-term effects, where we look at seed germination and the early development of the plant, but also at long-term exposure, where we expose the plants for a longer period of time and look at all the physical traits, but also what is going on within the plant, and looking at biomarkers, for example. And for the acute test, we should see that there might be some indication that the root length and also the shoot length are inhibited. However, these are only preliminary results, and statistical analysis have not been performed yet, as we completed this experiment last week. And for the chronic experiment, we see kind of an opposite effect when we look at lettuce exposed to polystyrene, where we potentially see a positive impact of fresh weight, for example. And in this experiment, we also want to look at biomarkers, what is going on within the plant. And again, these are only preliminary results. However, this early work shows that there might be some potential impacts, but we have not looked at these in details. And I would like to emphasize that it's too early to look at trends across species, but also between polymer types. But it's still important, as this is the first step in a series of experiments. We are also involved in the mesocosm experiment, where it's good to see the interaction between the soil, the plant, and many other organisms. That's why we will be performing plant experiments. So moving away from the hydroponics, and also in the mesocosm to test under more environmentally relevant conditions. So thank you very much for your attention.
Thank you very much, Laura, for this great presentation and on showing, even though only preliminary results, but we can see that there's further work ongoing, which will be turned into deliverables later on. So make sure that our stakeholders are well aware of it and can follow up on it. And now I would like to follow up with our next speaker, Salla Salonen from the Finnish Environmental Institute. The floor is yours.
Hello everyone, so my name is Salla Salonen and I come from the Finnish Environment Institute, Syke, and I'm leading work package 3 on the impact of micro and nanoplastics in PAPILLONs project. But now I'm talking to you about the field experiment, which actually many work packages are working together. Okay, thanks. The objective of this study is to study the potential effects of mulching film residues in a real environment. So as Sam already told us, we have different levels of biological organization to study, like simple laboratory experiments in controlled environments, and then in these mesocosm studies that Sam showed us, where we have more interactions but still controlled systems. And but this is then in real field environment where we actually lack the information. And we have there present all the interactions with different biota and also in organic environments. And we can also study this in different climatic conditions. So we look at soil properties, microbial community and processes in vertebrates, including earthworms, endothermic worms, microarthropods and microfauna, litter degradation, and then crop yield and quality, and plant physiology and biochemistry. And we also study the fate of microplastics and plastic additives by taking soil samples from grains and earthworms. Yes, so we are studying this in different climatic conditions from North Finland, from Germany, and then from South from Spain. And this is the experimental design we have at these fields. We are studying two types of plastics, LDPE, which is a conventional plastic, and starch PPAP as a biodegradable plastic. And these materials are from grinded pellets that are made from recycled mulching film. And we use two concentrations, 0.005 and 0.05%. And these are actually really like relevant concentrations. So we are not looking at higher concentrations that would not be environmentally relevant. And then a control plot. Yes, and then we have these three countries, Finland, Germany, and Spain, and we follow two growth seasons this year and next year. Now I'll show some photos, what we have been doing, and these are from PAPILLONs partners, so thank you for everyone for the photos. So first of all, we did a pre-sampling at this site to get some background information about the soil properties, microplastics, plastic additives, microbial community and activity, and earthworm community. Then last spring, we spread microplastics on soil surface, and then these particles were mixed in soil with a rotavator into 10 centimeters. Then at this field, barley was seeded. This was a species that could be grown in every climatic conditions. And we also did this litter degradation experiment, so-called feedback approach, which is commonly used, so that we actually bury rooibos tea and green tea bags in soil, and then they stay there, in this case for 2 months, and then they dig them up and weigh them and see how much the mass has lost. So this is a method that has been used also in other projects. So we have a kind of clue. The results can be compared also to other projects. And you can see that when we started, it was the field were green, and then near to the harvest season, then picking up. And during the growth season, plant samples were taken to measure physiological and phenological analysis, like surface area and necrotic tissue, but also samples for biomarker analysis in different stages of the plant development stages. Then we also, of course, had the harvesting time to measure then the yield and grain quality, and also take samples for plastic additives in grain. And after that, we did the soil sampling by collecting composite samples to analyze soil properties, microbial activity, microplastics, plastic additives, and then DNA samples were taken separately to be sure of that there is no DNA contamination. And the next step was the sampling of invertebrates. We have sampled this in Finland already for microarthropods and engitrate worms, but this is something that is coming in Germany and Spain a bit later to wait until the soil gets more moist after the dry summer. And earthworms in addition to this. In earthworms, we are not only looking at the abundance and community structure, but also take samples for microplastic and plastic additive analysis. And soil animals, these invertebrates, are important also, not only in the way that they are important in the soil processes as well, but they are also food for above ground organisms like birds or small mammals, so they are kind of road also to the above ground food web. Okay, so next step, we will have a lot of data. Actually, the first step is to analyze the samples that we collect and then analyze the data. And we are using the encrypted labels that when we send the samples to other partners, they don't know actually which treatment is under which code. And yes, these fields are maintained with agricultural practices, that's normal practices. And then next sampling will be next year of the harvest. Okay, thank you.
Thank you very much. Now we have Rachel Hurley from NIVA, leader of Work Package 2, to present their work on the reference material.
Wonderful, thank you very much. Yes, I'll be talking a little bit about the work we've been doing producing reference materials for the project. I'll start by sort of introducing what reference materials actually are. So they refer to small plastic particles that can be used for analysis and phase and effect testing. So we take agricultural plastic source materials and grind these up to make batches of micro nanoplastics. There is a lack of these in the kind of availability widely outside of the project. And this is not just related to agricultural plastics, this is also across the microplastic research community, that often we lack reference materials that mimic the particles that are actually found in the environment. And there is a need to kind of move towards more environmentally relevant micro nanoplastic reference materials.
These batches should also be sufficiently large so that we have enough material that can be shared across different research groups, different studies, so that we can work on the same material and track different effects, different phase and transport processes, for example. So we can harmonize some of the work that we're doing instead of individually creating small batches of reference material for each individual study, and then kind of undertaking work that then can't be compared as easily. And there's also a need for these to be kind of sufficiently homogeneous in terms of their characteristics as well. So we need to make particle size ranges that are constrained. We need to know more about the morphology of these particles, and there needs to be as limited variability in these batches of reference material. In the context of the Papillon project, these reference materials are essential for the investigation of environmental processes, so phase and transport, testing of impacts, so effects, for example, on crops or biota. They're also used for quality assurance and quality control of micro nanoplastic analysis. So this is essentially as like an analytical standard. And we can also, in a similar way, use this to facilitate harmonization between these micro nanoplastic analyses that are also undertaken. And like I said, we need these reference materials to mimic what would occur in the environment, so from the derivation of agricultural plastics. Unfortunately, there are several challenges that are associated with the production of micro nanoplastic reference material. The lack of material previous to the project and in the research community is certainly not anything to do with lack of effort. It's associated with a number of challenges in producing these. So some of these challenges include, for example, obtaining particles with relevant particle typologies. So getting the particle size ranges that are of relevance, and getting the right polymer types is also a difficulty. And then also getting small particles, so nanoplastics, for example, that can be quite challenging to produce these plastics from different polymer types and get them to that small size. And there's also challenges in terms of grinding this material. Some polymers are easier to grind than others, and there are sometimes challenges in producing large enough quantities of these reference materials, so often having to use, for example, commercial grinding companies to actually make enough of this material for scientific experimentation. And there's also a lack of harmonization in the research community related to the characterization of these reference materials. So there is not yet a standard for what is required to effectively characterize the materials that we're using. And this can then obviously have an impact on the interpretation of the results when we don't necessarily know all of the details about the particles. In the Papillons project, we've addressed this need. It was not without its challenges. It's been an interesting journey to actually produce these materials. But we have produced now several large batches of different micro nanoplastic reference materials, and they are derived from relevant agricultural plastics. And we've also added in the synthesis of nanoplastics in order to get those small particle sizes needed for some of the experiments. And we're now undertaking thorough characterization of these materials, and that's happening right now. And we're trying to set a standard here for what characterization is needed, so that within the project we can interpret the results that we find related to phase or effects, but also that in the wider research community that we can encourage a high level of characterization of particles of reference materials in the future. Thank you very much.
Thank you, Rachel, for underlying the need for harmonization and characterization within this field as well. Finally, we have one last speaker from the Papillons project to contribute. So please, the floor is yours, Elizabeth.
All right, thank you. Everyone probably needs a break, so I'll not talk too much in detail about this analytical part, but we all know what we're talking about. We're talking about agricultural plastics, and for this part of the project, we are looking at the two different types, the polyethylene and the starch PBAT. So the aim of this part of the project is to find an analytical method. So our research question were, of course, how much of these plastics are in different types of agricultural soil, and how can we measure this with a fast and reliable method? So that was our main point. So we are trying to establish an analytical method for these plastics, or these LLDPE and the PBAT. And we want to test this on different agricultural soils. And we want to test it to see if we can do a good analysis both with soil treatment and without soil treatment. So the best and fastest way would be to do everything on soil that we have not treated. So we can just put some soil in a cup and analyze it quite quickly. And I say cup because the method that we're using is called pyrolysis GCMS, and I don't have time to explain everything in detail, but I want you to know what this is. And that comes in the next slide. So what we do, we have these reference materials that we have in NIVA for the PBAT and the LLDPE. We put this in some soil and mix it well, so we have representative samples. And then we've put this in our pyrolysis GCMS. So the point with the pyrolysis is that you heat your sample up at very high temperatures. So for this project, we're using 590 degrees. And what happens then is that your polymers present in your sample will be broken down into smaller pieces. And we can measure these pieces and find out what type of polymer were in our samples. We can do this for all types of organic material, but recently it's been used for plastic analysis. So we compare these the molecules or the pieces that we get out of our analysis to our reference material, and then we figure out how many types of plastics do we have in the sample and what's the quantity of them. So here's just an example of what we get out of this. We get these pyrograms, and for the PBAT, we look for these markers, we call them. So for instance, if we have an environmental sample and we don't find these markers, there's probably not any PBAT present. So this is just from our experimental setup where we're testing the method. And very short about the results. So we have now set up an analytical method and it's been validated. However, we still need to work a little bit on improving it. We see that if you have a high organic content in the soils, this impacts the quantification method using pyrolysis for both of the plastics. So the next step is to look more into the soil treatment. So the treatment of the samples before we do our analysis to remove organic content. And also if there are other things we can do with the samples to improve the quantification. So this is where we're at. This is just to see what we're looking at. I didn't put the scales in, but these filters are approximately 15 millimeters in diameter. And we want our samples to be in the middle, as you see here. So we're talking about very, very small soil samples that we can use for this. So representative sampling and being very accurate on what we're doing is very important for pyrolysis work. But so far, this is very promising, and we're excited to keep working on this method. Thank you.
Thank you very much, Elizabeth. Right now, we only have one more presentation, which will be done by our project manager, Luca Nisotto, who will speak now a bit of a different project, but equally important in the fight against plastic pollution. So, Luca, I'll give the floor now to you.
So I will keep it short. I want to thank everyone. I think that despite the technical problems we experience as usual when organizing hybrid meetings involving different places in the world, we managed to have a message told. We will have a discussion. I believe the discussion will be confined within the group in this meeting. So thanks really for those that came physically here. I just want to argue that, of course, there is a clear, strong demand from making policy, from developing industrial strategy, and lack of sufficient knowledge. And this has been recognized in strategic documents, including the FAO report. It's not easy to fill up this gap in the short term because science cannot give up on quality. Okay? We will fail our mission miserably. So for this, you need to be patient. We should avoid taking a rash decision. We need to spend time to build consensus within the scientific community, as we saw even before there has been some difference. opinion and takes time to understand each other. Different disciplines are involved here. There is an entire area, academic area linked to agricultural science, and there is an environmental area. We are just starting talking to each other. It's already a difficult result. For this, we need to create workshop, working group, scientific panels. And I briefly mention now the existence of an emerging initiative called IKHAPP, International Knowledge Hub Against Plastic Pollution, which is actually sponsorizing and supporting, not financially obviously, but thematically, and this event. IKHAPP has a website, ikhapp.org, is on development. IKHAPP is going to be the home of an international network of scientists, an open network that will be devoted in giving advice, producing consensus, releasing synthesis of knowledge and guidelines, opinion and recommendation to decision makers, both at institutional level, governance, but also managers, because we recognize that we are all on the same agenda here. Despite we may have starting from different assumptions, I haven't found so far anyone suggesting that plastic pollution is good. So it's a difficult effort. We need to learn to understand each other. IKHAPP will be hopefully the place where we could build consensus within the academic environment and feed into the multi-stakeholder debate. We believe in science that is developed through validation by peer reviews. We believe in science that is communicated by panels rather than, although that sometimes is necessary, by individuals. We strongly believe that a panel communication is stronger than individual communication, and we believe in accountability, in clearance, transparency, and independence. So one characteristic of scientists that are involved in IKHAPP is they need to be independent. So this will be available. We will hear more about us. We are already involved in the negotiation part by supporting some of the work of UN Habitat, and we are seeking here to establish a relation also with UNEP and FAO. We really hope that this could be some piece of work we could do together in a more structured and systematic way. And invite all the scientists present today and online to consider joining this network. It is going to be a tough task because the international community wants to develop a global binding treaty within 2 years for plastic. Previous example, like the Stockholm Convention or the Minamata Convention, took more than a decade. We know that the plastic problem is a serious issue. We are unfolding an environmental pollution situation that incredibly went under the radar, even of science, for too long. We need to make decisions fast, but with this decision have to be science-based. Thank you very much. We can take our break, and I thank you also all the people present online. We look forward for the next event together with MINAGRIS. Thank you.
Thank you. I think some. I suggest we don't leave yet. I suggest for those that are online, I see still 73 people online, and we can take some questions now. And we continue till 1 o'clock here online for those online and those of you here in the room. And then we take a lunch break from 1 to 1:45, those that are here, and then we continue the panel discussion after that. But I suggest we take some questions now for those also that are online, because we also still have some plenary speakers that are online. And I hand over again to Sabas. And for all of you and also you online, I just posted the IKHAPP webpage in the chat as well.
Thank you. I hope you can still hear me. We gathered some of the questions that were asked in the chat as well, but we would like to make sure that the people here in the audience have the chance as well. So if you have a question, just feel free to raise your hand, and then we'll let you in. But first, I just wanted to ask our first speaker, Richard, on why do you think the UN is taking up this challenge now? What has changed? Luca has mentioned that it has gone under the radar for so long. And why do you think, what has been the change that has led to this global binding treaty on plastic to begin with? Oh yes, and I have to say, I have to ask each panelist to come here and talk to this microphone so that the people online can hear us as well.
That's a very broad question. I think it's the scientific community that has raised the issue, and evidence has come through from marine litter. The marine environment, the plastics in the marine environment has been very visible, and that drove science and policymakers to work on that issue, and that gradually has raised awareness of the actual issue in soil. So that's my brief answer to that question.
Thank you. I just wouldn't mind if you go away, because I have another question, which is based on your presentation. We have heard that FAO is working on this code, and at the same time we have discussed that there's a plastic treaty. Could you reveal us how these two can be in synergy, or are these parallel initiatives, or what would you say the connection between these two are? Thank you.
I would first of all like to emphasize that these are complementary, so that they're all working, both working in the same direction. They are different things, and as we heard, that the international agreement is requires consensus from all the parties to agree what is actually in it. So the scope will be potentially could be limited because of achieving this this consensus, and it provides obligations on governments. A code of conduct can actually be a broader thing. It has the same objectives, but it will be focused specifically on agricultural plastics. So it's got a narrow focus. It's not just about plastic pollution, but it's looking across the whole of the life cycle. It's looking at food security, food safety, nutrition, and all the sustainability criteria. And it will potentially include obligations for all the different stakeholders. So farmers, manufacturers, distributors, end-of-life management, recyclers, collectors, and so forth. Because it's not consensual, it's not legally binding, it's easier to obtain consensus. So potentially the time frame for establishing the code of conduct could be shorter than the international legally binding agreement. I hope that answers that question.
I think it perfectly does. Thank you for the clarification. Now I would address the question to Mr. Bernard Lemoine. So the question is, what do you think would be the consequences of a ban on plastic regarding food security and the EU's production? Thank you.
Well, the banning is a very good idea. Well, we are talking about the principle of precaution. I'm talking about the principle of reality. You are not going to ban the tractor, otherwise you will not have any production anymore in agriculture. I want to tell you a story about the cotton field in China. Millions of hectares are planted with cotton, and millions of hectares are using plastic. You understand that the cotton production is just strategic for China and strategic for the world. My shirt comes from the cotton coming from China. If we are not using plastic in cotton, there is no more cotton to be produced. This is clear. This is clear. However, we have identified the negative impact of the practices today in China with the machines, the way they are handling it. And the Chinese people is well aware of that. They have identified the problem and they are working hard to fix it up. So my point is to say there is no way, no need to ban the plastic. Otherwise, the production will drop drastically, and we still need to feed the mankind. Okay, we were 7.5 billion people today, 9 billion tomorrow. We will still need plastic. What we want to make sure of is to take care about the negative impact on the environment. And one of the good ways is, as that has been said before, is to inform the farmers about practices, to provide them with technical information how to do it the best way. It is also to create and to provide services of national collection scheme. You understand, and you have seen it with the presentation of Pierre de Lepinot, you understand that we know how to handle it, we know how to do it, we just have to use that knowledge somewhere else. So, yes, we need to increase the knowledge about all these impacts in the soil and so on. But we need to identify also where are the areas where there is no solution for the handling of the waste for the farmers, and then act. And if we have some recommendations to do to the public authorities, is to enforce the necessity to create those collection schemes in a sustainable way to make sure that we reduce or even eradicate those negative impacts.
Thank you very much for that answer and for giving a clear example on it. You have mentioned one of our online speakers, so I'm going to address him as well if he's still around, Mr. Pierre de Lepinot. We have received an online question asking, is your company doing initiatives on microplastic as well? I hope you are still within our reach.
Yes,
thank you.
Yes, as I answered in the chat, yeah, no, we have no specific action towards microplastic. Let's say our mission, as I explained, is mainly to implement a collection scheme for all of the plastics. Yes, it could be the next step to have some much more information about what could be impact of microplastic, but we have not yet critical issue on that point. We have no concern on microplastic in France.
Thank you very much for the answer.
There is one other study called Biomalek, studying about microplastic in soil and biodiversity.
We just heard from the audience that there is another study dealing with these questions called Biomalek, if I'm not mistaken. That is correct. Finally, we have another online question. I think that could be answered by Sophie maybe, so I would like her to get here as well. It is on, do you think that a subsidy on non-plastic alternatives to mulching films be useful in reducing plastic pollution? And if yes, to what extent then?
A non-plastic mulching, that's what you're
non-plastic alternatives to mulching films.
Yes. Well, I spoke today only about biodegradable polymers substituting the conventional plastic films, but there is also research being done on using organic material, biomass, as mulching material. It's unsure whether these provide the same benefits to farmers as agricultural mulch films. So that research, fortunately, that kind of research is being done. I think those kind of materials, also paper mulch, could be used as alternatives. These have also been proposed by the FAO. And I'd like to say or add, the NGO community absolutely acknowledges that agricultural plastics contribute to food production and that we have to feed the global community of people. Where was I going with this? Yes, it is, and I'm a little bit hungry. Well, I'll get back to that maybe in the panel discussion. Sorry.
Thank you very much. Exactly. I think I'll raise the last point, what was discussed, being hungry. So I think we can close the meeting. I would like to thank all of our speakers, both online and offline, who could join us today. And we would thank everyone in the audience as well, both here in Athens and online. It's been a long meeting, we know that, and we apologize for some of the technical hiccups, but we do believe that we could still provide some insights both into the research of Papillons and MINAGRIS. We will further collaborate on these issues, and as you could see, there's a developing research community and cooperation between different partners. So we would like to underline the fact that if you feel you have something to say, experience or insights on some of these issues, then feel free to address both topics. We will go on with our deliverables as well. So make sure that you subscribe to both projects on their social media accounts, check their websites regularly, and we will try to be in touch with you as much as you can. If there are questions that haven't been answered yet, we will try to make sure to take note of that and come back to it. I will ask the presentators as well if they can upload, we can upload their PPTs online as well, so you can follow up later on as well. Finally, thank you once again for everyone and the host university, the Agricultural University of Athens, that could have provided this nice venue and opportunity for us to be here in person, in present for the first time. So we'll be back, and I will just give the floor last time to Anna. Thank you.
Hi, sorry, so I just want to remind us, we just started, and this is our third stakeholder forum, and there will be many more to come.